All right. So this one asks us to write the equation of a line that passes through this point and is parallel to this equation. So I'm going to look at this a couple ways. I'm going to solve it two different ways for you. Some of you look at it algebraically, and some of us can look at this as graphing. Okay, the problem is some of us don't pick either way to look at it to solve. We just sit there and go, oh, I don't know what to do. Now, the things you do know, you know that the equation that I'm doing has to have a parallel slope to that one. And what do we know about parallel slopes? Who said that? Say it again. They don't cross. Parallels do not cross. Ma'am? They never cross, so what will their slopes have to be? If they're not going to cross, they got to be the same. If they're any different at all, they're going to cross each other. Okay? But if they're the same, they're never going to intersect. Okay? And so let's graph this one first. Okay? All right, so this equation here has a y-intercept of 3. It's going to go down 3. It's going to go right 2. And that's what that one looks like. So if I'm going to have an equation that's parallel to that, I know that it's going to have the same slope because my ruler represents a parallel line to that line. The only thing I've got to figure out is where it starts because I don't have the y-intercept given to me. I have the slope given to me. I just don't know where it's going to start or where it's going to cross the y-axis. So there's two ways we can do that. One, we can do it by graphing. I can plot the point -2, 4. This would be a whole lot better if I had graph paper. You really can't do this way without graph paper, but we'll make it work so you can see it, and I can perform the slope. So therefore I would go down 3, and I would go right 2, and that point touches the y-axis if I perform the slope from that point. Some of us had issues that I work with you on that you wouldn't perform the slope from that point. You'd plot the point, and then you would go to the slope, and you would do it from the origin. Here's another issue that I saw with a lot of people is they would take this coordinate and write it as the slope -2/4. I don't understand, and so this is a coordinate, this is a slope. Okay, the coordinate is a location on the graph, the slope is the amount of change from one point to another point on the graph. And so if I do this, and I plot it, and I perform the slope from the point it says it's got to pass through, then therefore it's going to pass through the y-intercept because, and if it doesn't do it, I think there has another one over here that doesn't cross at it at the first move. Just keep performing it till it does cross the y-axis, and you'll be able to see it. This one just happened to do it in the first move, and so therefore if I write this equation, y equals -3/2 because it's parallel slope, so they have to be same. And where does this graph cross the y-axis? At what coordinate? Where does it look like it crosses the graph? It crosses it right here. So what coordinate is that? 0, 1. Okay, so this would be +1 since it's positive. Now, those of us that want to look at it algebraically, okay, we know that we're going to write it in y equals mx plus b form, so we can plug in for the variables we know. This is the one that we don't know. That's the one we got to find. The ones we do know is I know that this is an x value because it's an x coordinate. I know this is a y value because it's a y coordinate. And I know that this is my slope because they're parallel. So I can plug those in and go. Okay, so it's going to be 4 equal to -3/2 times -2 plus b. Now, we're going to solve for b. So when we solve an equation, we work order of operations from bottom to top. Okay? Now, I have to simplify this side first because this side is an expression first. So we simplify, we go from top to bottom first. So this is an equation at which I go from top to bottom and then bottom to top in the same move. So I combine these like terms right here because it's multiplying. That's going to be negative 3 times negative 2, which is positive 6 over 2 plus b. What is 6 over 2 reduced down to? 3 over 1, or just 3. I got adding and subtracting on the b. I need to get the b by itself, so therefore I need to create a 0 right here by subtracting. B is going to equal 1. So I get that the same way. And so therefore I know that my equation, why does every one of these equations have x and y still in them? Why does x and y have to remain? Do y'all remember? Because I have seen it to where y'all do it algebraically, and then when you do this, you plug the negative 2 back in for the x, you plug the 4 back in for the y, and now you got 1. So really I don't have any variables at all. Why do I have to have variables in the equation? What do they represent? I hear somebody mumble over there. It's the domain and the range. I have to have an input variable to generate an output. Okay? And what you need to see is those inputs and outputs are coordinates on the graph. So if I plugged in negative 2 right there, I'm going to get 4 for the y, and it would be on the graph.